Yes, I'm Ryan Barrett, and I am a drone pilot and IT professional that I run my own business, and I've run a number of kind of side businesses as well. Many of them related to photography, drone videography, now some drone modeling. Um, really just an enthusiast about technology and trying to see how we can push the boundaries of what we can currently do, and try to figure out with this current technology that we have, what are the next things that we can hopefully move towards and allow us to create a sustainable future doing really interesting things with hopefully technology that's not priced out of the average person's range. So what we've been doing here, Jonathan's had me working and helping out with some modeling and lower cost drone work. So using drones that are not as expensive as some of the commercial drones that you'll see in use, which can be tens, hundreds of thousands of dollars. These models we're going to see here were done with a drone that was under $1,000. So it was Mavic 3 Pro that we used, or Mavic Mini 3, sorry, and Mini 3 Pro, but this could also be done with the Mini 3, which is also even cheaper again. So these models were taken up north, in the Toronto conservation area, uh, north of uh, Markham here. And this is a plantation that they have. Um, I don't know if Jonathan can probably provide a little bit more information here regarding the specifics of the site, but they have a large number of trees that they're planting, and we hope to model each plantation to allow them to do some monitoring, um, further, furthering their collection. You don't have to have somebody wandering through the field every single time you wanted to do a quick update and check on the trees. So this was a little bit of a test run, and we were able to very easily fly a pattern, fly a mapping route, and then take that from there. And we have all these 3D models that were generated. You can easily identify each location that the trees are planted. Now, certain types of trees we found were a little bit easier to see. Any of these coniferous trees in here, it's very easy to tell the tree size. You can kind of calculate that and compare it to a previous model. If we were to take more in the future, you can compare this one and the next and see how the trees are growing, maybe watch for some discoloration if there's maybe some trees that aren't growing as well. Even between these two sections here, you can see these ones on the left are a little bit more yellow. These ones are a little more red, or a little more green, sorry. That might make them maybe indicate something if you're looking at the tree's health. These plantations weren't as easy to capture because they were very early in the season and no leaves had come out yet on these deciduous trees. So you can compare with the shadows in some of the models. So you can count trees, see which ones are alive, but they were not quite as easy to see. So that might be some of the limitations we might have to work around in the future, trying to do more of this work with this type of drone. So that was one model we had here. It was a little bit more of a high pass where we flew over a little bit higher altitude to capture more of the site in one go. I'm going to switch here to another one.
Clear something. Okay. Clarendon. Yeah. Conservation area. Oh.
So here's the site as per satellite view. So you can see that the quality is not exceptional when you look at the adjacent satellite imagery. When you compare it to the imagery that we managed to capture here, you can see the much more detail that we're able to capture. You can see individual trees here. They've all got a little bit of a protective wrap on them to keep wildlife from damaging the trees as they're first growing. And that is something that's a little bit more apparent to kind of separate them from the grass. So things like that to pick out trees or whatever it is you're trying to identify from the natural environment are definitely very helpful. So if I go into here, I should be able to pull up the 3D model of that one. And then we can poke into that.
So this is the kind of stuff that we Jeffers got, you know? Okay.
So you can see this one is flown quite a bit lower. You have quite a bit more detail in each individual tree. And I was just researching a paper that Jonathan had given me here, and it goes into the kind of the specialization and the pros and cons of each different modeling software and what they really excel at or what they struggle at. This project had initially been modeled in WebODM that we're looking at here, and through this paper, they'd suggested WebODM, while is a fantastic software for certain things, it doesn't excel as much in high density point clouds, which is what we're looking at here. The density has some room for improvement. If you look, that there's not quite as much detail in the finer objects, such as a tree, for example. You'll lose more of that. Now, if you're doing something that's a building that hasn't have so many little tiny details, that's just fine. So definitely lots of room for further development and to see what we can get out of this. But I think this is definitely a very promising trial run here that we can work from and see how to improve going forward. Do you have any other questions there, Jonathan, regarding this?
No, that was great. What was the other software that you used?
We were using Metashape. I don't have that running here today. It is a little bit better with the fine details. That's by Agasoft, but it's not as cost effective as the WebODM here that we're using. So depending on use case, WebODM is probably sufficient for most uses, but as we're seeing here in this model, it is not quite as detailed as the data we'd collected is capable of producing. Right. So they all kind of have their ideal algorithms. And one of the reasons WebODM tones things back a little bit is you end up with a much more consistent model without as much noise and incorrect data. It jumps to conclusions a little bit less, where if you include every single point, like some other softwares might, I want to say Metashape probably is capable of committing this error where you'll have data that isn't correct, and that'll be included in the model, and it'll end up with more work to clean it up later, but at the expense of losing some of that finer detail when you don't include those error points.
Right. Yeah. And then, sorry, go ahead. Question.
Alex, I wanted to say this is at Clairville with TRCA and Acer setting this up with Sustainable Coburg's drone and Matt and Jonathan. Just want to say that's where it is. It's just north of a little bit of in north of Etobicoke, and at a dam near the Clairville Dam, just to give you a location.
Yes, sorry, thank you, Alice, for chiming in with that. Yes, it was the Clairville Conservation Area.
And now, if a teacher teaching CAD, computer assisted design, in a high school, wanted to use this 3D model of the landscape, would you be able to extract what's called a digital terrain model, which is the slope of the land from WebODM?
Yes,
or do you
absolutely.
Have to use oh, you can. Okay.
So this is, as we saw here when I went back and I put this into, if you view the map, it's already georeferenced. WebODM has already done that. So they already know kind of the starting elevation, and that can directly be plugged into another software such as ArcGIS or whatever is being used. And you're also able to export quite a bit of, you have quite a bit of flexibility with the exports that you do from WebODM to import it into other software, depending on what you want to do with it. Their software is real nice for looking at the model and interacting with it within its own bounds, and I guess at the extent of seeing how it fits into a map with satellite imagery. But from here, yes, you're absolutely able to export it and put it into whatever other software you want to use.
For example, the CAD teacher, the local CAD teacher said, if I can get a step file, then I can bring it into Fusion 360 or SolidWorks, which is what the engineers use to design their green and gray infrastructure. Does this, can you export it as and I don't even know what step file stands for, but that's what he said.
Yep, it's a 3D model file. I believe it can be exported. I haven't exported it directly to that, but it does support a large number of file formats. And at very least, it could be converted from one universal format to step file if there was that preliminary step required in the middle. But no, absolutely, it works
so
with
then
anything industry standard.
Once this teacher has the step file and he can bring it into a CAD program, then he was going to use it along with the drone georeferenced capturing of the campus to design a rain garden on the campus slope of the hill. And that hill or that campus is just north of the Chris Garrett retention pond, which they just finished dredging. And I think they dredged it, well, this one was 23 years and it cost $1.1 million. There's a larger pond where we planted trees. And then across the street, there are two smaller ponds. And I believe they dredged all three of those little ponds. Yes. And when they did that, they had to remove a lot of the vegetation to get the heavy equipment in to remove the soil, the contaminated soil. So part of the project would be to say, how can the school campus use low impact development or green infrastructure to reduce the amount of runoff going into that retention pond and remove some of the pollutants from the water that's running off of the parking lot. And that is his goal next year. And hopefully we can use what's being designed here and the hackathon in November to continue this amazing work by our youth who are learning from the experience of the adults who are intrigued with this technology.
Big move. Big move.
Yeah, so I mean, this is cutting edge because I don't know that there are many high school students that are capable of doing this or teachers that are capable of teaching it. But we do have the capacity to do that, and maybe later this afternoon we'll see some evidence of that. But I just want to add that, and thank you, Ryan, for this. This is the technical part. We also have to think about the art part. So as Ryan was presenting, you could see that he was gaining experience with this software, and it's not a science. Like John Hayden said earlier, if there was a science to a perfect pitch, then we wouldn't be here today. So it's the same thing with this software. If there were a perfect solution to 3D modeling of green infrastructure and running simulations of rain runoff, we wouldn't be here today. And so part of it is thinking about not just the software, the technical, but the art, the experience of working with the technology, and then taking it outdoors and testing it, ground truthing it. And that is the big question. How do you build the keystone that keeps up the wall of computer science and technology on one end, and the citizen science and the ground truthing and being outdoors planting the trees like we did on the other side?
Yeah, thank you.
Very well said.